All right, here's what we want to do today. Well, here's what I want to do today. I shouldn't speak for you. I'm not sure if you want to do this or not. But we have a little bit of loose ends associated with the bit of constructors, and that is dealing with how constructors work when you're dealing with inheritance and subclasses. I don't know if that's even going to be essential right away, but I think it's kind of important. At least I think it's important to kind of tie up that loose end, because we covered constructors and how they work, and I want to make sure that we tie up the loose ends about constructors before we move on. So that's item of business number one. Second item of business is to look at the book's tip calculator example. If you remember, I sort of made a simpler tip calculator, and then there's one in the book. And the way this works in a nutshell, and let me talk to you about the strengths and the weaknesses of this approach to take in class. The way that many of the lectures are going to work will be that we'll look at a sample from the book, which is good because then you can read through it, you can get their explanation, get my explanation, and the hope is that both those explanations together will make some sense for you. The strengths of that is, again, I'm fairly well in sync with the book, and so there should be a disconnect there. The downside of that approach, and the thing that I try to be leery about, is I don't want to be focused on just learning the specific things in that application without having the broader perspective. So on occasion we'll go and we'll tweak the examples and we'll modify them. So I guess you should be aware that any examples we're talking about some specific, we'll talk about some specific coding things and all that, but you know that you kind of have to take and run with it and apply it, you know. In other words, the examples aren't the be-all, end-all. The examples are there to illustrate some points and to sort of expand your capabilities in this area, but really, you know, you got to take with it and run with it. You need to do more than just be able to duplicate the example. So we'll try to do that through the lectures. All right, first off with constructors. All right, let's talk about what we have seen so far with constructors. Rule number one is that every class always has a constructor. A class gets its constructor one of two ways. Implicit, which means that the compiler generates. Or explicit, whereas the programmer generates. So if you do not define any constructors, the compiler generates a constructor for you. All right? That's what I mean by implicit. In other words, it's there, it's implied. You don't really have to do anything. If, however, you define any constructors at all, then for a class, then that implicit one doesn't get generated. All right? So there's no like middle ground regarding a class. Either you're doing everything or you're doing nothing. All right? So either you define all the constructors or you define no constructor and let the automatically generated one go. Number two, you could have multiple constructors. And with multiple constructors, how you can have multiple constructors is different arguments. In other words, a different combination of number and type. So, for example, you can define one constructor that takes a string. you can define another constructor for that same class that takes 2 strings. You can define a third constructor that accepts an integer and a fourth constructor that accepts 2 integers. So as long as the combination of number and kind of arguments is different, you can have 2 constructors where both the number and the type of argument match in order. So I could not have 2 constructors that accepted a string and an integer. All right. The reason is if I called that constructor, which one would take? All right. The Java virtual machine is smart enough to know if you call a constructor, it looks for the matching constructor, the constructor that matches those arguments. So if you call a constructor with a string and an integer, it will find a constructor whose argument is a string and an integer. But therefore, you can't have 2 of them. Otherwise, the constructor would have no idea, or the compiler would have no idea what to do. In general, whether we're talking about constructors or other methods, this is known as overloading. All right? And the idea is simple. The idea is that we can define a class. A constructor, again, is what creates a class. Sometimes when we create the class, we want to initialize some of the properties for it. All right? And the multiple constructors allow us to do that. So for example, let's say we wanted to have a customer class. All right? And we might have a constructor that took a string for the name of the customer. So we could call that customer constructor, and in one shot we could create the customer object, and we could initialize the value of the customer name. So we call the customer, we give it a string, and then that constructor is coded to take that string as an argument and assign it to the instance variable for the customer. Or we could have a constructor that has 2 strings, maybe the customer name and the customer email. And when we call that constructor, if we give it just 1 string, it'll set the name. If we declare it with 2 strings, then the name and email get set. Now, this is something that we're going to code, right? We're going to have our class as instance variables, and we're going to write the constructor to take the arguments and initialize the instance variables for them. Constructors get invoked by the new statement. So this line here, customer C equals new customer, does 2 things really. First thing it does is it sets up a variable. You know, think of a variable as a named memory location, a place where we're going to store something. Now, in the case of objects, we are storing a pointer to where that object lives. Objects get created in the heap, so they're out there. And what we're really storing in the variable is not the contents of the object, but a pointer to the contents of the object. And that becomes important when we talk about like assigning one object to another and so on. All right? Because we're not changing the actual data, we're manipulating the pointers, and we're setting one variable to point to another object. So this creates the variable. This says, hey, I'm going to have a variable called C, and in that I'm going to store a customer. This is what actually creates the customer object. So new customer is invoking the constructor. And specifically in this case, it's invoking the no argument constructor. Which again, you remember, if we do not define any constructors, the compiler will define this one for us. If we define any constructors, then the compiler will not define the no argument constructor for us. And it's then our responsibility to define that no argument constructor if in fact we want one. All right? That's kind of where we let off last time. Any questions about that? Now let's talk about inheritance. All right? when you deal with classes that inherit from each other, let's say we have a customer class, and inherited from that customer class is a nonprofit customer. It follows our rules for inheritance, right? A nonprofit customer is a customer. A nonprofit customer can do everything that a customer can, but there may be some special things that we know about a nonprofit customer, or special things that nonprofit customers do, or do some things in a special way. For example, if I'm not mistaken, for a nonprofit customer, there's no sales tax charged. All right? So that might be different than a regular customer, the manner in which sales tax is calculated. All right? So the key thing to remember about inheritance is that when you're creating the object, sort of all the levels of the object have to be created in order from superclass to subclass. All right, that might be a little confusing to hear. Let me tell you what I mean. In other words, when the object is being created, the constructors for the customer run prior to the constructors for the nonprofit customer. They have to. All right? They have to. In other words, you have to have a customer before you have a nonprofit customer. If you think about it, it makes sense, right? In this routine and in the constructors for a nonprofit customer, we may be manipulating some of the variables in the customer class. Well, those variables need to exist before we can manipulate them. So the constructors for the superclass runs prior to the constructors of the subclass. Now, let's assume we created no constructors, all right, on either of these two classes. If we created no constructors on either of these two classes, then if we call the constructor on the nonprofit customer, the compiler-generated default constructor would run on the customer, then the compiler-generated default customer would run on the subclass. And it would be created. Wouldn't do any initialization because it's the default, but both of them would run. So in the constructor for a nonprofit and the constructor for the subclass, I either, again, implicitly call the constructor of the superclass, or explicitly call it. All right? If I do not have anything in the subclass to call the superclass's constructor, then it's going to run the no argument constructor. All right? So if my constructor for nonprofit customer accepted a string argument of the nonprofit ID, let's say, nonprofit code. And I had a line that said something like nonprofit code equals the argument in here. And that was an instance variable associated with a nonprofit customer. I am not invoking the customer's constructor. I'm not explicitly invoking it. Therefore, but still, regardless of whether I explicitly invoke it or not, the superclass's constructor has to run. So therefore, the no argument default constructor on the customer will run. So there better be one there. All right? So either you have to define it, or you don't define any and let the default take effect. All right? So if we call this method explicitly calling the superclasses constructor, the no argument constructor will be called on the superclass. Which means either, again, we haven't defined any, and the default constructor gets run, or we have explicitly defined a no argument constructor. Let's say we have a different set of constructors. Or let's say we have a different constructor, one that accepts 2 arguments as string, and sets a nonprofit code and sets the customer name that's an instance variable up in customer. The way you would likely do this is you would likely define, I put that line in there, but then I decide, no, that's not really where I want it. I would more than likely define a constructor for customer that accepts a string argument and sets the customer name equal to the argument. However, the way I have this written, since I haven't explicitly called that constructor on the customer class, it's going to call the no argument one, and this one won't get run. So what I need to do is I need to tell it, hey, explicitly run the superclasses constructor and set that. If I didn't do that, what would happen is this. I create the nonprofit customer object with a new. I have to construct the customer first. All right? Therefore, it's going to try to create the customer with a no argument constructor, and there isn't one. Why isn't there one? Because I defined a one argument constructor for customer, and therefore I would get a compile error on this. I haven't explicitly said what to call, therefore, by implication, I'm going to call the no argument constructor. And since I've defined a constructor for the superclass, there will be no default constructor created, and therefore this will end with an error. What I have to do again is say, hey, call the superclasses constructor and give it the necessary arguments. So that's what that line means. If I'm calling a superclasses constructor explicitly, it has to be the first line in the constructor. So I can't do some other things and then have super at the bottom. Just like super, I have the ability from one constructor to call another constructor for the same class. And for that syntax, instead of using super, you use this. And it too must be the first line in the constructor. If you do a little bit of thinking about that, that means that you can't call a superclasses constructor and another one of your constructors from the same constructor. You either have to say super or this as the first line, or nothing at all, in which case it calls the superclasses default no argument constructor. Now this could be a little confusing. All right, when we get into examples like this, it probably will become a little more meaningful. But I want to sort of plant this idea in your head now, so that you'll be ready to look for it. Let's see how relevant it is, and let's see where that comes into play in our example application that we were looking at last time. The simple you remember in the simple calculator last time, I had two classes. I had a meal, and the meal had three attributes. A cost, a level of service, and whether it's to go or not. And I created two, I think, constructors on the meal class. One that accepted all three attributes, the cost, the level of service, and whether it's to go or not, and initializes those variables. Notice how I'm calling the set function to do that. That's a good little consistent thing to do just in case you have some validation in there. If I call, and then I have a one argument constructor that just contains the cost. All right? And notice what it does. If I call the one argument constructor for meal, I call this and the three argument constructor, and then I default two of the attributes. So if I say new meal and give it an integer, or a double rather, for cost, it will take and it will call this object's, in other words the meal class's, three argument constructor and pass the argument cost in here, pass the level of service, one for average, and pass false for to go. So it will invoke this constructor, and that constructor will go do its thing. This is a nice way to provide ways of initializing a class by allowing people to either explicitly set some values or allowing some defaults. So in other words, I can call the constructor and set the three attributes, the cost, the level of service, and whether it's to go or not. Or I can call the method, the constructor, and only give it the cost, in which case it defaults the level of service, and whether it's to go or not, defaults the level of service to 1, defaults whether it's to go or not to false, and then calls this method, and those get set. Let's look at the subclass. The subclass in both cases simply calls the superclass's constructor. So that's what super means. So in other words, if I create a banquet class using the three argument constructor, it simply goes and turns and calls the meal class's three argument constructor. Now you might ask, why do I need these at all? All they're doing is calling these superclasses constructors. Well, if I did not have these constructors defined, then what would I get? Well, the compiler would generate the no argument constructor. The compiler generates the no argument constructor. All right. What's going to get called on the superclass? The superclass's no argument constructor is going to get called. Lo and behold, the superclass does not have a no argument constructor because I've defined two constructors, and therefore that no argument one doesn't get generated. So I'd either have to remove these constructors, or I would have to explicitly code a no argument constructor. I think some of these will become more apparent as we work through and as you create some of these things. So I just want to introduce this notion to you, and you know, we should build on this later on throughout the course. All right. Let's go and look at the textbook's tip calculator. It's a little more involved. And again, the idea is that we're going to take what we know already and we're going to build on that by adding new stuff in all of the components. Let me run this, make sure we have the right one. And we do. So let's take a look at this. All right. This has, instead of the ability to choose a level of service, it has a place for us to put in the amount of the meal. Then it creates a table for us. And that table consists of a tip, assuming that you want to do a 10% tip, a tip assuming you want to do a 15% tip, and a tip assuming you want to do a 20% tip. So if I put in, let's say we'll keep the math simple on a Monday, and say it's a $100 dinner. Notice that under 10% it says $10, 15%, $50, 20%, $20. And then it shows a total going across, which is simply the amount of the meal plus the tip amount to get a total amount. We also have, though, sort of a wild card. What if, for example, the service was pretty good, but maybe not at the 20% level? We have a little slide here that allows us to pick the level that we want to do. So we could say, well, it was pretty bad. It was even worse than our 10% level. So let's assume that they get a 9% tip. And it'll show you the tip of $9 and a total of $109. On the other hand, it's like the wait staff did an outstanding job, you know, and we just hit the lottery, so we're really happy. So we're going to give them a great tip. We're going to give them a 50% tip. All right, in which case it goes and does that. So, what's different about this? All right, a couple things are different about this. First of all, and I'll pass this around in a minute so you can play with it. Notice that as I type the amount of the meal, the calculation changes. So, the simple tip calculator I had before, you typed in the amount and pressed calculate, and then it went and calculated it. So this is a little bit different way to invoke that method. So I go in and I type in that I had a $234 meal. As I'm typing it in, it's doing a calculation. So that's one thing that's different. Second thing you'll notice that is different is my results are different. All right? Remember in the simple tip calculator, the results, the screen was linear. It was like just one thing right after the other. Here we have some things side by side. We have a label for this. All right. We then have a text box. We then have a label for tip, and we have 3 little slots for that to fit in. So if we were doing this with the same kind of layout that we did the last example, everything would just be like, boom, just going down the screen. But it's not. There's some of the stuff that's side by side. Lastly, we have a different control. Instead of we had a text box